Welcome back to Nick Does Maths. Today we have our first sequel video. We are carrying on. We are doing a follow-up to our previous video, so go check that out, in which we proved these three results. All right, the solutions to cos of 2n theta is 0 look like this. We've proved this if we do have thetas of this form, we get this nice little relationship, which is going to be very important for us in a second. And then we also got, using de Moivre's theorem, this nice general result. Now we need to prove this. Now there's a couple of things that are going on. Now our gut reaction is to use that, but there is no binomial coefficient here, which had me a little bit stumped at first, but we will get there. Now, so instead we've got this mix of tans and cots. Now where do the cots come from? Well, we are supposed to use all of these, and we're adding up tans, but we do have this little ditty here. And this is sort of telling me, well, what's the link between tan and cot? Well, I know that tan theta is cot of pi over 2 minus theta, right? And that's going to be important for us later on. The next thing is, well, this seems to be our big thing to go on because we've got sums of tan squares, and we know that cos of 2n theta is 0 if it's of that form. Well, okay, so let's create a polynomial that looks like this. Set it equal to 0. Now we know that this has solutions of this form. All right, where theta m looks like this. Now how many do we have? We have m between 1 and n. Well, that's quite good. Now we want the sum of a bunch of tan squared. So how about we investigate the sum of these roots? The sum of these roots. Now, this polynomial, right? What do the sum of the roots come in as? Well, the sum of the roots is the coefficient, all right? So we want here the coefficient of x to the n minus 1. In a cubic, the sum of the roots is the coefficient of x squared. In a quartic, x cubed, etc. In fact, it's minus the coefficient of x to the n minus 1. All right, so there's the sum of my roots. The sum of my roots of this polynomial, i.e. the sum of these things, has to be the coefficient of x to the n minus 1, which is minus... now, the coefficient of x to the minus 1 is also the same as the coefficient of x to the 1. All right? So the coefficient of x to the 1, looking at this, is minus 2n choose 2, which is minus 2n minus 1 over 2, which is minus n 2n minus 1. Okay. Now, how are we going to get the cots in? How are we going to get the cots in? Who let the cots in? Right. So what we are going to do is this. We are going to pair these up. Because fundamentally what I've got here is I've got theta 1, theta 2, theta 3, theta n minus 2, theta n minus 1, theta n. So if I pair these up, right? So if I pair these up, tan squared of theta 1 plus tan squared of theta n. And then in this sum, right? Tan squared theta 2 plus tan squared theta n minus 1. Now, the thing is that, of course, theta 1 plus theta n is pi over 2. Theta 2 plus theta n minus 1 is pi over 2, and so on and so forth. We proved that here. Put in L is 1, L is 0, L is 1, L is 2, L is 3. And then we can use this fact. All right? So tan of theta n is just cot of theta 1. Tan of theta n minus 1 is cot squared of theta 2. Now, let's take n to be nice and even, so that we've got a nice even bunch of stuff here. Let's do that here. Right, so we'll take n as even, i.e. n is to capital N. All right, so n is to capital N. And this will give me the result that we want. So now I'm not summing all the way up. I'm not summing all the way up to n. I'm going to take half of it. So in fact, when I do this, I am summing up to n over 2. And n over 2 is just n. All right? So by doing it this way, what I've done is I've taken the second half, right? So I take the sum up to n over 2, and then the second half of this sum, I've splattered back down here in the form of the cot squareds. So I get, now these minuses cancel out as well. I get the sum. I've done it with m, I probably should have done it with k, that's fine. So we're adding up to half of n, so only up to n, because the second half of it is included in there. Tan squared of, now what's theta? They did it with r, I'm going to do it with m's. Theta m was 2m minus 1 over 4n, but little n is 2n, so that becomes 8 capital N plus cot squared of 2m minus 1 over pi. And that is going to come out as this, but then little n is 2n, so that comes out as 2 big N, 4n minus 1, if I manage to keep that on the screen. So the real trick is here when we pair them up. We pair these going together. And I know, well, I don't need the tan of that one because that's just cot of that. I don't need the tan of that because it's just cot of that. I don't need the tan of that, it's cot of that. So I've folded the second half of this series into that cot squared term, which is really, really cool. Now, if you're looking at the original question, there is another identity to prove, but that I will let you do yourself. That is the case, what if n is odd? What happens if n is odd? And I'll let you go figure that one out yourselves. Let me know how you do. Drop something in the comments to let me know how that went for you. Don't forget to like, subscribe, hit the bell for notifications. We keep these coming, trying to do some really interesting maths questions at the moment. I'm Nick, and I will see you next time.